I wanted to introduce the 4 guiding principles, and these are something that I've found over the years practicing in this field as key considerations when designing any kind of a living shoreline. Any one of these, if any one of these are not addressed properly, the living shoreline may fail. So the top principle is considering the length of open water or fetch, which I just described, and we'll go into a little bit more later. Controlling drainage, both overland and below. Understanding the natural angle of repose for soils, and protecting the base of the slope or toe. This first slide addresses considering the length of fetch. Two real-world situations are depicted here. Both of them exceed the 1.5 mile fetch condition. You can see the results. On the lower left, the bulkhead actually failed during Hurricane Sandy, and on the lower right, the gabion section failed because the gabion system was not at an adequate height to protect from the storm wave and storm surges that were occurring. We're actually developing a project right now on the lower right condition to extend the toe protection and provide a living shoreline above that. Second condition is, second principle is to control the drainage. As I mentioned earlier, overland flow is very important. It's best to pitch back the land up to the shorefront, back landwards, so that water doesn't travel over the surface of the land down the face of the shorefront, and also to control the underground seepage that might be occurring so that you can avoid slumping. Third principle is understanding soils and soil characteristics. You can see in the upper right what a natural angle of repose is. That's the angle when you pour soil out on the ground or create a stockpile. It has a natural angle it tries to achieve. I would recommend that practitioners do not try to install vegetated treatments alone on anything steeper than the natural angle of repose. It's bound for failure. Always understand your soils before you get involved in developing a practice, and making sure that you have that natural angle considered before you start using vegetation alone. If you do have to exceed that angle of repose, then you're going to require some additional structural support. And again, one of the last parameters that I find very critical, and typically the Achilles heel for many designers, is they forget to protect the toe. Toe protection is absolutely essential. If the toe isn't protected from battering both on a low-level routine basis or during storm surges, the shoreline restoration is bound to fail. I call this slide the good, bad, and the ugly. You see various different conventional techniques as well as some more innovative techniques, all with varying degrees of success. And honestly, I can share with you every one of these treatments is within a 1 mile stretch along Rocky Point on Long Island. So you can see all kinds of examples if you go out and take a look. I wanted to walk you through how to examine different options for treatment. When you're considering living shorelines, there's many different things that constitute living shorelines. As I said, the definition is very broad. Living shorelines can consist strictly of vegetation, or it can include erosion support, erosion control materials. Another case is plants themselves can actually be used for structural support. And the last case is on steeper sections, more headland situations. You can use plants and structural materials as hybrid type of living shorelines. I'll go through them one by one. This is the same slide as the previous one in my opening talk on Hempstead Harbor, where all that rubble was removed and the site was regraded Additional soil was taken out and a cap of 6 inches of clean fill material was placed for a planting medium. And you see volunteers in the upper left putting those plant plugs in. Living shorelines comprised strictly of vegetation are only recommended for very low energy environments within coastal coves or protected back bay areas, not on headland situations with high energy. This slide presents some of the results of that planting you saw earlier, the before condition during installation and 2 years later. You can see within 2 years you've got a healthy and functioning ecological system established. The second condition is when you're encountering a steeper slope situation or a slightly higher energy environment where you might not be in a protected cove, but let's say along a riverine area or a flat beach area that's more exposed. In these cases, vegetation alone won't be the easiest thing to establish. You usually need to incorporate some form of erosion control practice with that, and that might include erosion control mattresses, coir pallets, or coir logs to provide that toe protection that we talked about earlier. This slide depicts the coir protection at the toe that I was discussing earlier. On the upper left, you see the coir installed and plants actually growing through the coir log, and then live plants up on the bank behind that. In the lower right, a similar situation, much larger coir logs, and that location is at the Fresh Kills landfill, where we created a tidal creek and then graded back the fill material to create a 3-acre tidal marsh. The third condition, again, now we're going up in the energy environment as well as the slope condition. This would be on slopes of 2 to 1, not any steeper than that, but in this condition, you can actually consider using plants as structural support. You see on the lower left a photograph of live stakes, which is basically dormant plant material that's cut in the winter and kept chilled until it's put in the ground. On the upper right, you see a brush mattress installation. Those live stakes that you see are placed on the ground in the dormant condition. And the idea is that they provide actual physical support for the soils underneath, as well as a wave dissipator and energy dissipator. I'll get into that more in the next couple slides. You'll see on this slide a couple of different examples where we have live stakes and machines. Live stakes are the same thing seen earlier with the cut dormant stakes that are placed into the ground. When they get inserted 2/3 into the ground, the lower portion grows roots, and then the roots become the stabilizer for the slope. The upper portion sprouts into a living shrub. So you can see the installation on the upper right, and then 4 months later, how that installation turned into basically a green living wall. Brush mattresses you saw in the earlier slide. Basically, this is a slide where on the lower left, you see a stone, I guess you would call it a stone revetment. It was something that was illegally placed and had to be removed to meet jurisdictional requirements, and we had to come up with a green alternative. So in this situation, we were in a tidal cove, and the slopes were steeper than 3 to 1, more like 2 to 1. So we specified a brush mattress. You see the brush mattress on the lower right, and then a couple years later, how it turns into another green living wall, a lot more attractive than the stone that was there earlier. The fourth condition would be when you go through that vegetative treatment potential rating sheet, you find that there's very low potential for stabilization with vegetation alone. This is the condition when you have to incorporate structural support. On slopes that are steeper than 2 to 1, more like a 1 to 1 situation, or higher energy environments. Example of an example of a hybrid structure is shown on the left, the live crib walls. And then again, as I mentioned earlier in this talk, a vegetated riprap or vegetated revetment, where the stone has integrated plant materials. So you get both benefits of stone toe protection as well as the habitat benefits of the vegetation above. I'll quickly go through the slide. This is the construction of a live crib wall. Live crib wall is basically put together like a Lincoln log construction. You can see that in the central slide up above. To the lower left, you're looking at a live crib wall on the steep section of the slope, and it folds right into a brush mattress on the left steep section of the slope. This is the result several years later. The slope has been entirely stabilized and has become a green living wall, something that we had to consider because the agencies on Long Island had a moratorium on bulkheads and stone revetment on tidal creeks. And it worked out very well, and it's providing some wonderful habitat and also helped to preserve the woodland up above it. One thing I wanted to emphasize in summary about living shorelines, there's some critical things you have to consider as a practitioner. You really need to build into the contract a very professional design team comprised of either ecologists or landscape architects working side by side with engineers or marine engineers. That collaboration is important so that you get the proper balance between structural and vegetative support in a living shoreline. During the design phase, you need to consider the long-term performance standards of the agencies. In several cases we deal with in New York that the agencies will dictate an 85 to 95% performance standard for any material that's being installed. If you can't meet that performance standard, if you assume that within 3 to 5 years that material will not stand up to the potential, consider a different alternative. Don't even go with living shorelines. Think of some of the other hybrid protection mechanisms or more conventional techniques. So you want to design for success. Be sure to consider that when you're picking the right solution. And then also remember that post-construction monitoring is very important when it comes to living shorelines. One size does not fit all with living shorelines, and also because they are living, it's always good to get back and assess how they're holding up after a year or 2 years. A side note, whenever we write specifications for living shorelines, a 1-year guarantee doesn't seem to work. You typically need a 2-year guarantee on your plant materials so that you have time to come back in and replace something that didn't withstand the initial shock of installation. So 2 years is recommended as a minimum. And the last slide I wanted to share with you, this is an example in Conscience Bay on the Long Island Sound area of a multifunctional living shoreline, one that was installed between a local roadway and a tidal shorefront that formerly was covered with strictly invasive species and a bunch of rubble. That material was all removed. The area was regraded, and we created bioswales in its place, which provides now flood control for the local area, stormwater treatment, wetland enhancement, as well as shoreline retreat. As water levels rise, we now have a natural buffer for the shoreline to retreat back in. I wanted to thank you for allowing me to be part of this discussion and just quickly cover, we've gone through several design considerations, we've covered 4 guiding principles, and I wanted to leave everyone on this call with a challenge. Approach your site visit feasibility analysis with a different way of thinking. Start first with what can you do with less rather than more in terms of structure. If you can consider that, you may have a successful living shoreline that you can incorporate into the shorefront instead of a conventional practice that has very little ecological and coastal benefits associated with it. And again, monitoring is essential to success. I'd be happy to answer any questions, Elizabeth, if there's any right now.
Thank you, Laura. You've definitely got me thinking about it, and you know, I'm sure our audience as well. So I invite the audience to submit your questions to me using the chat window. And I guess the first question we have for you is, how did these living shorelines do during Hurricane Sandy, and how did that compare to the traditional hardened type of structures?
Well, you saw in some of the earlier pictures that even the conventional shoreline hardening structures, if they're not designed properly, can fail just as much as any other practice. Some living shorelines practices did not stand up well to Sandy because they were not, the site was not properly assessed prior to installation. But others have thrived and done well. A key to success is making sure that you evaluate your project site carefully, taking into account the type of wave energy and whether or not the orientation is on a headland or a protected cove. If the shoreline treatment is selected properly and installed properly with good controls, it has a lot more flexibility than some of the conventional shoreline techniques. If there is any damage that a living shoreline must sustain, obviously the repairs to that living shoreline are going to be a lot cheaper and a lot easier to implement than it would be to replace an entire section of bulkhead or an entire portion of undermined seawall.
Thank you, Laura. We do have a couple questions about how you deal with contamination on living shorelines. So I'm hoping you can touch on that. And I know Frank McLaughlin is going to talk about that as well in his presentation.
Okay, Elizabeth, the way we've done it in the past, on every site that we've gotten involved in, we typically do a soil investigation before we even, develop a shoreline treatment system. On the very first slide that I presented for Hempstead Harbor, where the rubble was there was a high likelihood that we could have encountered contaminants. We did take some soil samples, sent them off for analysis to be sure that the site was suitable. On other situations where we don't have the option of having clean soils, for instance, in the Fresh Kills landfill situation, we did not know what we were going to encounter. In that case, typically we over-excavate soils, and then in the design plans allow for bringing in some clean fill material to be placed and provide the growing medium for the plant materials afterwards. I have not been involved in a separation barrier between a contaminated area and an uncontaminated area, but I know that that does get incorporated into living shoreline designs, and we're working on something like that up in Connecticut right now.
Well, thank you, Laura. And I remind everybody to please submit your questions using the chat function. Again, you can access that by taking your mouse and pointing to the green bar at the top, and then you'll see your chat window. You'll be able to open that. And I think at this point, we'll do one more quick question here, and then we'll go over to the second part of our presentation, and we'll have time for more questions at the end of the whole presentation. So the next question we had was just about the timing of doing shorelines. I guess because it's vegetative in nature, does that sort of impact, seasonally when you can construct these?
As far as timing and installing living shorelines, the best way to deal with it is to view the living shorelines, let's say, in the most adverse condition, usually in the winter, and design up the appropriate strategy for protection to be installed in the spring. That gives you enough time for plant establishment through the summer, and then a better likelihood that plants are going to be surviving through the winter time. So I'd say evaluating the site any time of the year, but preferably in the winter or during severe conditions, so that you can get a proper analysis and not miss something during the design. And again, allowing for a full year of growth, I think, is appropriate when you're installing a living shoreline. If you put the plants in too late in the summer, sometimes they haven't established root systems that are hardy enough to make it through the winter or through browsing from waterfowl. So it's always good to get plants in before July, let's say July 15th, if you're putting in a living shoreline.
All right, so I have a couple other questions that go back to contamination and talking about, really it's more of a comment that there needs to be, and I guess you can comment and see if you agree with this, that there needs to be flexibility in permitting of living shorelines, particularly for wave attenuation structures that also provide ecological benefit. Coastal processes are different in a river or creek, especially in an urban area, than in a bay or ocean. And I guess, is that kind of something that you agree with, or any comments on that?
I'm smiling because we've been fighting that battle for the last 20 years. Depending on which state you're in, there's different regulations in effect. Obviously, one of the key guiding principles I talked about is protecting the toe. It's very difficult to establish healthy, thriving, living systems if regulators are not on board with allowing introduction of stone or some other structure at the toe where it's needed to break that wave energy. So from the New York perspective, we're trying to jump that hurdle right now. I know in Maryland they already have regulators that are in line and have already allowed for perched beach or perched wetland systems to be put in. I'm not sure the case in New Jersey, but yes, I agree. If the regulators come up to speed with some of the design considerations and requirements, then the broad brush of you should use living shorelines everywhere, that myth can be dispelled, and we can look at things from a more logical scientific standpoint and get a lot more successful applications on the ground.
Okay, Laura, I'm sorry, we've got one other, I think, very quick question for you, which is, how much soil is needed to determine the angle of repose?
Not much. I mean, quite honestly, you can take out a tile spade or a bucket auger and take a bit of soil and take a look at, what the actual properties are in the field, or you can go back and refer to your county soil survey and find out what engineering properties are for the soil that are mapped in that location. So you really don't need much. Also, when you go out to investigate a site, you can actually see what the erosion has already done. How are the soils holding up? What's standing in the field after erosion event will give you some idea of what the natural angle is going to be.
Thank you so much, Laura. Well, please hang on with us as we proceed to the next section, and you'll be available at the end for some more question and answer discussion. So moving on to our next presenter is Frank McLaughlin. He, for those of you that have done any work in New Jersey on brownfield sites, you've probably already met Frank. He has been a dedicated NJDEP employee since the late 1980s, where he is currently a brownfield project manager. He is absolutely a tireless advocate for the city of Camden, and he is the lead NJDEP liaison for the Camden Collaborative Initiative. He is also the co-chair of the Brownfield Community of Practice for the Urban Waters Federal Partnership related to the Delaware Estuary. Frank has degrees in chemistry, geology, and environmental sciences, and he is currently an adjunct professor at Ramapo College. So with that, Frank, once I find you in my list here, I am going to turn the ball over to you. Hey, Frank, I think we're seeing your screen now. Oh, just a second, Frank. I got it. Your audio isn't feeding through yet. Now, go ahead. Hold on. We have to.
Elizabeth, I think we're up and running now.
Now we are. There you go.
Hi, thank you for those nice words, Elizabeth, and thank you for inviting me to present some work we've been doing in Camden, which I hope will assist other communities in living shoreline applications in more urban communities, which are greatly needed because that's where our people live and often have brownfield sites and other opportunities to remake their shorelines. There's a long list of benefits to living shorelines in Camden and in other urban communities. Hopefully we'll get to talk about them in our question and answer session. Because of in consideration of time, I'd like to get right to a little bit of the story at a site in Camden, and hopefully it'll provide benefits to you. In addition to what Elizabeth kind words, I work for the New Jersey Department of Environmental Protection Office of Brownfield Reuse. Our office works in 31 communities in designated brownfield development areas. These are areas of continuous brownfield sites where we work in partnership with local municipalities and their redevelopment plan, their visions for their communities. I also chair the department's, the Camden Collaborative Initiative, which is an initiative that works with the City of Camden, some nonprofits like Cooper's Ferry Partnership, the Camden County Municipal Utilities Authority and Camden County folks, and also the Environmental Protection Agency Region 2, the Sustainable Communities Program. So we have a great team of folks to look at brownfield sites and even broader environmental issues in Camden. Camden has, in addition to a large amount of brownfield sites from the decline of manufacturing that many other cities have also experienced, Camden also has a deteriorated water infrastructure system, one of the oldest in the country, and unfortunately under-maintained over the last few decades. And you can see some pictures of flooding in one neighborhood in Camden, the Kramer Hill neighborhood, that we'll focus on for the rest of the talk. And by the way, of issues in Camden, residents wanted flooding to be resolved as the most important environmental issue to improve their quality of life. This is an aerial shot of the Kramer Hill neighborhood, which is in the far northeastern section of the city of Camden. The Kramer Hill neighborhood is a working class neighborhood with a stable population, but they are isolated from one of the most beautiful urban waterfronts in the state of New Jersey. From the left to the right of your screen is a 2-mile stretch of brownfield sites and one large landfill that effectively cordons off this vibrant neighborhood from the riverfront. In addition to being brownfield sites and landfills, these sites, being neglected for several decades, all of them have ecological assets, including eagle foraging habitat, very valuable fish migration, migratory fish habitat, and also in-stream water quality benefits from freshwater mussel habitat. This is an aerial view actually looking towards the northeast from about where Philadelphia is and the North Camden neighborhood at a former landfill called the Harrison Avenue landfill, which was the city dump that operated in Camden from 1952 to 1971. It was at the confluence of the Cooper River, which drains 3 counties in South Jersey, and exits at the back channel of the Delaware River on the left side of your screen. The Harrison Avenue landfill is a solid waste landfill. Again, it operated from 1952 to 1971. The landfill was never properly closed. It was basically left behind in 1971 and has now revegetated with mature vegetation. At the water's edge, there are endangered species. Eagles forage right from the site. Again, migratory fish habitat, freshwater mussel habitat. Over 1 mile of river frontage along 2 rivers, the back channel of the Delaware River and the Cooper River. Again, it's in the Kramer Hill neighborhood, where we've been working for about 10 years with stakeholders in our Brownfield development area program. And it is the largest brownfield site in the city. And in 2009, and one of the benefits of a long-term relationship with communities like Kramer Hill and Camden is we get to iteratively work with these communities on their environmental problems and also their environmental assets. And that led to a 2009 plan called the Kramer Hill Now Plan, which had an exciting vision and reuse for all the brownfield sites in that neighborhood, including the Harrison Avenue landfill. And as Laura was saying in one of the questions earlier, we're saying we need to approach living shorelines, brownfields, and landfills more flexibly as agencies, because communities don't want to see what is on the left side of the screen. When we started working early with the Kramer Hill neighborhood, the picture on your right, that's actually a picture of the landfill. The landfill does not look like a landfill. It looks like a mature forest, and again, has very high ecological value. And it had high value to the community because, again, it was their largest tract of land, and it was separating them from the waterfront. So they did not want the department to close the landfill in the way that often is done for solid waste landfills. Iteratively, over many years, starting around 2006, we've been having dialogue with the community, and they formalized their vision in 2009, and it's a vision much closer to what you see on the right, which is we just called it an alternative path. We can get into discussions in the Q&A later. But it turns out that the alternative caps are cheaper, much easier to maintain, and cheaper for construction, capital costs, and also maintenance costs. And that's an important consideration not only for a living shoreline, but also to the brownfield site or landfill adjacent to that. Here's an aerial photo looking actually towards the southwest, towards downtown Camden and Philadelphia in the distance. So you can see the wonderful proximity of this landfill and the waterway assets that it has. You can also see the row homes to the left of your screen from Kramer Hill. Again, we started intensive work at this site in 2006 by doing extensive remedial investigations of not only the landfill but the adjacent waterways. And we had the good fortune of being a recipient of a $59 million gift from the Joan Kroc estate, and that spurred a phase 1 reuse of the landfill. The Salvation Army Camden Ray and Joan Kroc Community Center, that's the framing you see on the lower part of the screen there, that will be opening this October, and the DEP working with, of course, the City of Camden, the Camden Redevelopment Agency, the Kramer Hill Community Development Corporation, Cooper's Ferry Partnership, and with our partners in EPA Region 2, we were able to fund the remediation of the Kroc Center, which again will open this October. Surrounding the Kroc Center is this beautiful shoreline that you see to the right part of the screen. But the working on the Kroc Center since 2006 presented an opportunity to do things a different way in the city of Camden, working with our local partners, of course. And you can see there's green remediation elements on that part of the Harrison Avenue landfill. There are 2,000 feet of bioretention basins, over 1 acre constructed wetland, all these things to maintain stormwater on the site so we don't add to the combined sewer system problem that we have in the city of Camden. Across the river in Philadelphia, they're dealing with the same issues where during significant rain events, the regional treatment plant in Camden cannot handle the treating of the copious amounts of stormwater, and there's a bypass, and then there's discharges of combined sewer into the waterway. And many cities in New Jersey and across the country are dealing with this combined sewer issue. And at the Kroc Center portion of the Harrison Avenue landfill, we were not going to contribute to the existing problem in the city by doing green remediation. I'd also add we beneficially reused 221,000 cubic yards of dredge material that came from the nearby channel, the Delaware River. Of course, we tested it. It almost exclusively met our soil, residential soil standards, and it has been used for the cap for this landfill and also for the foundation for the Kroc Center at a savings of the state of millions of dollars. But there you can see our Living Shoreline project area, the about 300-foot buffer along the entire western side of the Harrison Avenue landfill. And this is what it looks like after, again, the landfill ceased operations in 1971, and you can see what a landfill looks like after about 50 years of neglect, and heavily vegetated, mostly stable. You can see a riprap area where you see vegetation growing out of it, almost as good as some of the slides Laura showed you, with a stable base and vegetation above it. You can see on the right-hand side a picture of what we have: a broad intertidal vegetated in the warmer months by spatter dock, and you can see there's actually about a football field's length of vegetated intertidal zone looking southwest towards the Cooper River, and then also the city of Philadelphia in the background. We've done a lot of studies, not only chemical studies of the adjacent waterways, but working very closely with the Partnership for Delaware Estuary out of Wilmington, Delaware, who, by the way, have received 2 Living Shoreline grants for this project because of the value of the freshwater mussel habitat at the foot of this landfill. And there's a Philadelphia Inquirer article about 2 years ago. And literally at this time, the indigenous freshwater mussel beds are filtering millions of gallons of water per day of Delaware River water in the Philadelphia-Camden area. And the Harrison Avenue landfill presents a opportunity to do millions more per day. And we're studying the freshwater mussels now to understand how we can utilize them to the extent practical in our closing of the Harrison Avenue landfill. This is a picture of the Cooper River as it's exiting into the back channel of the Delaware River, looking northwest to a large island in the river called Petty's Island. So you can see what the landfill to your right, Cooper River to your left at low tide, and where the gentleman, Josh from the Partnership Delaware Estuary, is looking, that's where some of the most valuable freshwater mussel beds are that we hope to replicate further as we close the landfill. This is our working concept, again, working with the Partnership for Delaware Estuary and our local partners like Cooper's Ferry Partnership, like Kramer Hill Community Development Corporation. This is our working concept for one portion of the Living Shoreline in the critical area where the Cooper River exits the Delaware River. And, you know, we're thinking about not only stabilizing the shoreline, but also working out throughout the intertidal zone down to the low tide area, so we can improve habitat not only on the landfill and at the interface, the high tide interface, but all the way into the through the intertidal zone all the way to the low tide area where the mussels like. And we will be beneficially using many materials on the landfill to provide the habitat for the mussels and the submerged aquatic vegetation. We have plenty of trees on the landfill. We have lots of demolition debris that we just need to size properly to deal with fetch and other things that Laura talked about earlier, so we can maximize our habitat while not damaging our current habitat in this area. And thinking broadly, these brownfield sites and landfills are in communities, so we need to be sensitive to the community's needs, like access to the waterfront, open space recreational needs. We have, through these Living Shoreline grants, we'll be doing education and stewardship about the freshwater mussels and the value of the river environment, again, which residents and students are isolated from in Camden right now, but won't be for much longer. We also have to think about the tidal flooding and stormwater issues that we have in the city, but when we restore these brownfield sites and landfills, we can also reduce tidal flooding, stormwater, we can manage stormwater better, and also we can be thinking about long-term and how we make our communities resilient to sea level rise. This is just a depiction of some of the partners to the right, and these are our partners in our Camden SMART initiative, which is another initiative in Camden that started in 2011. Of course, the city, I mentioned Coopersbury Partnership before, and the Camden County Municipal Utilities Authority. Rutgers has been very valuable in green infrastructure education and managing stormwater. We work closely with the New Jersey Tree Foundation because the trees do a great job in absorbing water and making the quality of life in the city better. And this is a concept, aerial concept of the Harrison Avenue landfill when we finally realize our living shoreline and our landfill closure for a park. And I can get into the details if we have time in the question and answer. We're very excited that not only are living shorelines applicable to the Harrison Avenue landfill site and the Kramer Hill neighborhood, but also our more developed shorelines in Camden, where we're currently taking a 5.5-acre former brownfield site that was abandoned for decades, and we're turning it into a park called Phoenix Park, and we'll provide access to this waterfront south community to the waterfront, also kayak launches, stormwater management, and so many other great things. And I'm happy to talk about that project more if time allows. And in addition, phase 3 of this project, this Phoenix Park restoration, will be a living shoreline. So that is on to your right. And again, if time allows, I can talk more details about it. Okay, Elizabeth, all yours now for question and answer.
Thank you so much, Frank. I think, you gave us a lot to think about there. It's a really exciting project, and I look forward to being able to go there in the future myself. So with that, I'm going to remind everybody that you can click on the green button at the top of your screen, and you should be able to pull down the chat window. So please go ahead and submit your questions to me via the chat window. One thing that we had, it's a little bit more of a comment, but I'm hoping, Frank, that you can discuss this a little bit, is the issue of the potential of exposing contaminants in the aquatic environment during a brownfield site remediation. And this comes to us from the U.S. Fish and Wildlife Service. And, they're talking about a project that they're working on up in the Newark Bay, where they're teaming up with, it's Fish and Wildlife, it's Army Corps of Engineers, it's NOAA, it's NJDEP, and they've been working together collaboratively to develop some protocols for the remediation of aquatic sites that are contaminated, because they really want to ensure that any aquatic sediments that remain are sufficiently characterized, and they're characterized to aquatic standards, not to just residential standards, and that they're appropriately capped. And they have actually developed some guidelines for that. So that is developed guidelines, the Corps, the EPA, for the Newark Bay Burrow Pit, and that's to avoid risk of exposure to aquatic biota. So they want to talk a little bit about that, and then a kind of a second part on that is if the site has the potential to become recontaminated, either from upland sources or from nearby sources, and in this case, he's thinking the New York Harbor and surrounding waterway sediments that are typically contaminated with higher unacceptable levels of metals, dioxins, and furans, then it may be necessary to further remediate the site to maintain its chemical, physical, and biological integrity. And Fish and Wildlife is just saying that this is really a complex issue for, in this case, Region 2, but I would say for anyone who's dealing with these kinds of issues. And they're looking to have collaborative approach from many agencies and the public. So I'm hoping that you can comment a little bit on that, Frank.
That's quite a question, and I share that gentleman's concerns, and we've been thinking about those exact issues at the Harrison Avenue landfill and now at Phoenix Park. That last slide I showed. What I will say is that we spent about $4 million doing several phases of remedial investigation at the Harrison Avenue landfill from 2006 to 2009. And that included a pretty exhaustive vertical sediment profiling in the Cooper River, in the back channel of the Delaware River, at our site, and in all directions. It actually turned out that the Harrison Avenue landfill sediments, which we compared to, I believe, NOAA standards. We were very fortunate to have a gentleman named Greg Newman who works for the Department of Environmental Protection, and Greg works with NOAA on developing sediment standards. And in addition to, of course, Greg looking at sediment quality, we've been fortunate to have access to the Army Corps of Engineers Philly District. We have relationship with NOAA Philly. We also have a relationship with, obviously, EPA Regions 2 and 3, and also our local partners, in addition to our Partnership for Delaware Estuary partners as well. So we've been looking at this thing from a chemical standpoint, a recontamination standpoint, but also you have to look more broadly at these projects because you have a community sitting there, and also, as we found at the Harrison Avenue landfill, there's already great benefits. Eagle foraging, migratory fish, freshwater mussel habitat existing that is doing probably millions of gallons of water per day in situ treatment. In the first phase of our landfill closure, we're now managing stormwater much better on the site. So we're actually looking to harness the natural system to remove contaminants from the sediments. We know there's carbon sequestration and nutrient pollution benefits to the freshwater mussels and good vegetative habitats. So we need to look broadly. The contamination is an important baseline for us to look at, but we also have to look at the benefits of having the living shoreline, having resiliency, having connection to for the community to that waterfront. And so we have to put everything on the table to look at it. We've had a long time at the Harrison Avenue landfill to do it with many experts locally to nationally, and we were fortunate that the sediment quality at our site happened to be better. The worst sediment quality we found was actually where the combined sewer outfall exited at the northern end of the site. So the combined sewer discharges had the greatest imprint in addition to the background sediment quality coming in from the Cooper River and the main channel of the Delaware River. So that's probably not a satisfying answer to my a colleague at U.S. Fish and Wildlife Service, but we can continue the dialogue, and I'm happy to share the information that we have gathered at the Harrison Avenue landfill. So we're comfortable with our approach, even though we do have a contaminated site landfill in place.
Frank, I think that was an excellent discussion and really great insight on that, especially your point about looking at these more broadly with the benefits that they also bring to these sites and, cleaning up the environment. Frank, I had somebody ask if you could talk a little bit more about the Urban Waters Federal Partnership and the goals to address the shoreline restoration in that larger brownfield area of the Delaware River, including, you know, the various states, New Jersey, Pennsylvania, Delaware, and maybe you could talk about the other partners in that. And wait, before I do that, I am just going to say I realize that we're about 10 minutes over time for the Q&A, and we really appreciate all the people who are staying on to listen to us, but we certainly understand if some of you, you know, we're only scheduled for an hour and have to leave, but we hope that the rest of you can stay on. So with that, Frank, can you address that last question?
I'm happy to, Elizabeth. The Camden, Philadelphia, Wilmington, Chester zone of the Delaware River has been designated as an Urban Waters Federal Partnership area, one of 17 in the nation. We're really fortunate to have that designation. What this will allow is us to have more experts providing guidance to us in how we close this landfill, how we deal with other brownfields in Camden and our sister cities, Philadelphia, Chester, and Wilmington. I'm fortunate enough to co-chair one of their communities of practice, the Brownfields Community of Practice, one of 5 areas that the Urban Waters Federal Partnership is addressing with Simeon Hahn from NOAA. And we have great support, again, from Region 2 and Region 3 in this effort. We also have a long-term good relationship with the Army Corps of Engineers, the Philly District. So this is going to even enhance more the experts we can draw from to really get the greatest uplift when we close this landfill and our other brownfield sites in Camden. And again, we're happy to share, you know, our experience in Camden at this site with other cities, not only our sister cities in the Urban Federal Water Partnership, but elsewhere, because we also have a lot to learn in how our future waterways are going to look like at Camden City. So again, there's a website for the Urban Water Federal Partnership. We're very happy to be part of it. And again, bringing all your experts to assist in your project is invaluable.
Thank you, Frank. You know, I think it's a great initiative, and you know, one of the things I find also really interesting about it is how you span 2 different EPA regions and are able to get, you know, the expertise from both regions. So kudos to you. Next question is for Laura. Laura, I guess it's a little bit of a comment, a little bit of a question, talking about the need for wave attenuation devices, you know, considering that when you're doing a living shoreline. The definition appears to be too limiting. Say there's a need to restore a full suite of ecosystem services, including those provided by intertidal areas lost by filling and dredging. So, Laura, can you comment to that?
Sounds like that question has several parts. A full living shoreline component, a full living shoreline project will address not only the near shore habitat and the adjacent uplands, but submerged vegetation as well. As I mentioned earlier in the talk, site specifics have to be taken into account. The shoreline orientation has to be taken into account. If you are in a highly exposed setting, there's no other way to establish a full green shoreline or living shoreline project successfully without providing for some kind of wave attenuation, be that with a stone sill that would be placed in the near shore habitat slightly offshore from the toe of the stabilization project. That would allow a emergent wetland to develop behind it. And again, as I mentioned earlier, some agencies are for that type of practice and others are not. We're hoping that natural evolution will take place and regulators will start to consider those type of practices because they are, you know, an essential part in the proper in the establishment of living shorelines in more vulnerable locations. I'm not sure if I answered it completely, but I'd love to address that at length. If anybody would like to send in a question, a written question, I'd be happy to answer it by email.
Thank you, Laura. I think you answered that question. See, we had a comment from Sam Reynolds at, I believe he's U.S. Army Corps of Engineers, and he just wanted to let everybody know that, you know, they're really happy to be part of the Harrison Avenue landfill redevelopment project and some of the other projects that they're working on in Camden. But he also wanted to let everyone in our audience know that if they have questions about permitting for living shoreline projects, and I guess if they're in that region of the U.S. Army Corps of Engineers, which I believe Sam is out of the Philadelphia office, please go ahead and contact him directly for any permitting issues. He's happy to help out with that. So I don't believe we have any more questions that have come in. I believe we've gotten to all of them. But if there's anyone in the audience who feels that we didn't get to their question, please go ahead and resubmit it to us. And if there's anyone who had a question who hasn't had a chance to ask it yet, please go ahead and submit that question to us, and we'll give you a moment or two to do that. And while you're doing that, I will put up our slide about the NJIT tab contact information. Again, we have the hotline number up there. We have our dedicated email address and our website, as well as Colette, Santa Series, my, and Sean Groom's emails, so that you can contact us. Again, remember, our services are free, absolutely free. We have a grant from US EPA that pays for us to provide these services. It includes not only our services, but any travel that we may need and any supplies. So if you are in EPA Region 1 or EPA Region 3, and you are a government entity or a nonprofit, please reach out to us, and we're here to help. I am looking at my chat window. I don't see any additional questions coming in. So let me first thank everybody who took the time to be part of this webinar today. We really appreciate you taking the time out of your busy schedule to learn about creating living shorelines and brownfield sites. And we very much want to thank our presenters for today, Laura Schwanoff and Frank McLaughlin. And with that, we will close out this webinar. Thank you all very much.